Hello, everyone. My name is Gerard Gatch, and I'll be the moderator for today's webinar on the topic of design features of GMP scale MCS GP HPLC technology. This is one in a series of webinars on multi-column chromatography for applications in the production of protein therapies. Check out the complete series at biowebinar.com. Now, we understand you have limited time and came here to hear the content, so only a few housekeeping notes and we'll commence immediately with the presentation. Today's seminar is approximately 25 minutes long, leaving plenty of time to answer any questions you may have. This presentation is focused on a unique design, the unique design features in the new YMC twin column HPLC chromatography system that's enabled with the patented MCS GP technology. Today's speakers will present this GMP scale system and walk us through the design engineering of this platform. This is intended as only an overview of the major design components, and the technology has an array of features that are explored in depth in other companion webinars on such topics as the patented M-control automation, details on how the MCS GP process works, economic case studies, and a closer look at automation. These are 15 to 30-minute presentations by subject matter experts. So today's presentation is going to cover these topics. We'll quickly walk through the MCS GP process and benefits. A brief overview for those of you who have not gone through the more extensive explanation on MCS GP. Then we'll go through the overview of the system around its compliance and its functionality, major design component and control considerations, summarize that, and then have plenty of time at the end for questions. So today we have two presenters. Dr. Kathleen Milbachler will quickly review the MCS GP technology, and then we'll hand it over to Matt Bowie, who will walk us through the detail of the design. Dr. Kathleen Milbachler is an expert in the field of multi-column process chromatography and was instrumental in the development of these twin column systems, the entire platform at YMC. Kathleen holds doctoral and master degrees in chemical engineering and a master's degree in biomedical engineering. Matt Bowie is the project manager for YMC's process technology group, responsible for the development of this MCS GP platform. Matt's an engineer with a PMP certification, and he holds a dual Bachelor's of Engineering in Mechanical and Electronics and an MBA from Boston University. Now, please welcome our first speaker, Dr. Kathleen Milbachler. Kathleen?
Good morning, everybody. And thank you, Gerard, for this good introduction. And I'm looking forward to introduce to you today our novel MCS GP technology at the GMP scale. So let me first start with a brief introduction to the technology. What does MCS GP stands for? And I'm not only mean the acronym MCSGP, but also the technology. And why do I need to know this technology, and why do I want to use this technology? As Gerard already alluded to, we have a number of webinars which go in more detail, but I just want to give you here a brief introduction, so you can then go to the other webinars if you want to know more about it. So Chromacon has a patented technology. The cube we have spoken in other webinars, which has multifunctionality, which includes the capture SMB, traditional chromatography, sequential chromatography, and the MCSGP process. Approximately 5 years ago, we started with the development of the capture steps, which we scaled up to the GMP scale, and which is now implemented in the clinical manufacturing. This is an HPLC system which can do capture SMB, sequential and batch operation. It has been proven that it can be increase the productivity by more than 2.5 times compared to the batch process, and reduce the buffer consumption by 50%. That means for the user that you can reduce your needs of resin for the initial capture step, which is mostly important for monoclonal antibody purification, where you reduce the needs for protein A resins. Today's presentation will focus on the other functionality of the Chromacon technology, the patent technology, the MCSGP process, and we will introduce to you the GMP scale skids we have developed now at YMC Process Technology. These skids are HPLC skids at the time, and they can also operate traditional batch operation as needed. Again, there are a number of webinars posted where you can get more in details about the cube and the capture SMB. And so let me now start with the MCSGP process. In traditional HPLC purification, we have a problem concerning productivity. In analytical HPLC, we are striving for baseline separation, but this is not very productive, needs a lot of solvents. So to reduce the solvent needs in purposive HPLC, loads, injections are overloaded, but then there are product-related or process-related impurities eluding with our main peak. So we have to make a trade-off, either having a high pure product as shown on the upper left side, or we have more polluted product, but we have higher yields. And this trade-off we try to overcome with the MCSGP technology. And as you can see in this plot here, outlined very, very nicely, you know, what the capability of a batch process is. You know, either high purity or high yield in the process. And with the MCSGP, we can come to a point where we maintain the high purity and keep a high yield, and that means we have a high productivity in our process and need less solvents for the purification step. Again, you see on the left side our traditional batch HPLC process, where we usually discard the front and the back side fraction which are higher polluted with process or product related impurities, and we only collect the main peak with the high purity. Sometimes in batch chromatography, folks collect this fraction with higher impurity and then do an extra load at the end of the run. But with the MCSGP process, we can now automate this internal recycling of the impure product fraction in the front and in the back of the main peak. We also can apply in this internal an linear gradient or gradient formation in the elution. And again, this is an automated process where it does not need any interaction of an operator to proceed in the process. It's all programmed, as you will see later in the presentation. And I come now to the point, just MCSGP, the meaning of the acronym reflects the capability of the functionality, which means multi-column. We are running with 2 columns, solvent gradient, purification process. Again, details you can find in related webinars. But we just wanted to show on this slide the application which have been shown and multiple molecules on the bench, as here shown A, B, and C isoforms of monoclonal antibodies could be nicely purified with high yields, but also aggregates could be purified from a monoclonal antibody, or with peptide purification, pegylated molecules were purified applying the MCSGP process. It is also applied to oligonucleotide purification, as we have shown in other case studies, or peptide separation. In a case study, we could show the advancement of the MCS GP process for oligonucleotide purification, and here clearly the productivity was improved by more than twice the initial batch operation. The yield of the process increased from 60 to over 90%, and buffer could be reduced by 70%, which is very important when we are running with organic buffers. And also, if you think about this improvement, what does it mean for my overall process? So I have a higher productivity. So either I can scale down my upstream process to a smaller synthesis process or fermentation process, or I can reduce the downstream needs. So for instance, instead of using a 60 centimeter ID column, the process can be run with two 30 centimeter ID columns, which then also reduces the needs of the packing materials. In this case, it was a significant reduction down to 15 liters instead of 70 liters, which also means you need to reduce, you can reduce the needs for the skid sizes and the pump requirements for your process. And this is a significant reduction. Half of the flow rate is needed, and if we can reduce the footprint of our skids, this is important for our customers. And that leads me to our second speakers, Matt Bowie, who will introduce to you our GMP scale skid in more detail and highlight the specific functionalities of this unique novel system.
So as Gerard had mentioned and Kathleen had elaborated, MCS GP process is very efficient, but that also poses some technical challenge for our team at YMC Process Technology. But it makes possible by implementing some very great mechanical features. And today's presentation, I will guide you through some of them. So the first step, let's go through the P&ID of the systems. We have 4 pumps here. Pump A and C are dedicated for gradient. D are for solvent and dilution. All of them are capable of operating at up to 100 bar design and 80 bar operation. We try to achieve symmetrical design with minimum honor volume so that the MCS GP can implement successfully, because we have 2 identical columns and the pipeline have to be identical between these 2 runs. We also have several sensors and valves. Those are all dynamically controlled by the pattern and control. A standard, we offer 3 different models with the flow rate up to 8.33 liters per minute and column ID up to 45 centimeters. In terms of technical compliance, the system comes as standard for class 1 DIS 2. So that allows you to run different hazardous buffers and flammable buffers with ease. We also can provide an option for CE conformity, including ATEX Zone 2. Automation-wise, we can support 21 CFR Part 11 and also enable GAM5 compliance. So the system is designed for GMP operation and validation, and our team at YMC can help you to do that. When you walk around the system, you can notice several key components that make the MCSGP process possible. You can see the HMI here, the pulse unit for hazardous location. We have 2 pH and 2 conductivity on top of the system, 2 UV sensors here, and a cluster of 20 fast-acting valves in this area. We have 20 inlet valves across 4 pumps, and the pumps are special for this application because we have a combination between stroke adjust and servo motors on pump A, C, and D. I want to highlight the first key component, which is the pumps. We have 4 pumps in the system, and 3 of them have servo motors and stroke adjust. So this combination provides capability for the pump to run at very wide range. The highest flow, the ratio between the highest flow and the lowest flow can up to 190. So with that specification, you can run very shallow or steep gradient and at the same time achieve very good linearity. And these has been tested for 80 bar operating pressure with no problem. The second component I want to highlight is the fast-acting valve. You can see these are compact, very compact compared to the rest of the skid, and we stack them 20 valves of them in this area. And in that way, the distance between the columns and the valve are minimal. So that optimizes for whole volume very low. The construction of the valve is very simple, yet it's very robust and operating very fast. This one has been tested and proven for over 500,000 cycles. And that's enough for almost 10 years of continuous operation 24/7 with the valve switching every 5 minutes. And these are not new. These have been used for a long time, for over 15 years in other critical applications. And we select specifically for MCS GP application. All other components in the system are owned from major brands with global availability and service, Leica and Redhauser, etc. MCS GP process is very sophisticated, and we try to make it very simple and user-friendly with our automation platform here. These are factory talk platform, and you can see we have all information that you can imagine in the main screen. On the top, on the top right, we have the basic recipe information. In the middle, we have a current sequence. And on the flow path in the P&ID are highlighted so that you know what is happening at the system. As you can see here, we have a connect elution sequence where column 1 takes the flow from pump A so that it can elute through outlet 1. Column 2 check the flow from pump D, and that's through the one step to the second outlet, PSPO here. You can see it's very intuitive, and you can access different buttons at the bottom here that allow you to have a very quick access to different functions in systems such as totalizer, column management, engineering screen where you have high-level tools and configuration for engineering levels, such as pump tuning, parameters, remote access, enable, etc. Event, this is the event screen, and it's very important, this is a trend screen where you can configure different pens with different colors, different range, etc. I want to point out at how easy to create a recipe with our automation platform. So this is the recipe creation tools that we wrote ourselves by YMC. As you can imagine, you can easily drag and drop different symbols into the work area here. Noticeably, you can see there's a 2 sequence running at the same time. So we call it parallel recipe. Column 1 can run elution, column 2 can run gradient. And you can also loop it with different conditions here. And when you run the MCSGP process, you can see that we have a lot of data because one batch can last for hours or days. But we handle the report, which usually can be very long and take minutes or almost 20 minutes to generate with our self-developing reporting tools. Even the long batch, it can still generate in just 5 seconds. And this has all the information that you can have in this comprehensive format. The first is cover page, a recipe overview, and all the parameters. All the parameters in very easy to understand format. So this is exactly the format that we have in our design documents, and we can see the range, description, and all the applicable sequence will be printed out together with the event log and on the train. And because the MCSGP process can run for days or hours, you don't want to wait until the end to know what's happening or what has happened with your process. So our tools can generate the report instantly. So either it's for single cycle or multiple cycle at any time. You can also configure the report to include performance, also transition and peak analysis in this tool. So we have overcome a lot of technical challenges and make the MCSGP process available and possible. Many of you have been familiar with the cube for large scale and with the new system for MCSGP in GMP scale. We believe that you can take your chromatography process and production to a new level. So here are some highlights to our presentation and why I'm prepared to take questions. I want to point to the short wrap-up from our moderator, Gerard.
Hey, thank you very much, Matt and Kathleen. You've taken a subject that has a really broad and deep number of aspects to it, and you've distilled it into something that is very nice and concise. For more information, you'll receive an email from us in the coming days with a link to the recorded session, as well as documents that will further your insight on information that we've presented. This presentation was sponsored by YMC Corporation. YMC is a pioneer in chromatography going back to 1980, producing bench and prep scale, HPLC and LPLC systems, packing resins for large and small molecules, and analytical and prep scale columns. YMC is a global company with manufacturing and offices in over 10 countries. Just a reminder that other aspects of this topic are covered in the series of webinars, and you'll see these and more webinars on the topics of multi-column chromatography. Okay, now I'd like to bring it back to Kathleen and Matt for the Q&A. First question is, could you explain more details on how purity and recovery are both improved using this system? So Kathleen?
Okay. Due to the twin column arrangement, you're able to recycle the front and the backside fraction of your elution peak, which usually have higher levels of impurities. Through this internal recycling, you can obtain a high yield of your process, but also have a high purity of your product peak, which you're collecting. And that gives you the capability of maintaining both. Whereas in a traditional batch HPLC process, this fraction would be discarded, and that leads to the lower levels in yield and productivity. And this is through this automated switching that internal recycling can be accomplished. Again, I will refer to the other webinars to go into more details. Otherwise, I won't stop talking for the next hour. Thank you.
Very good. Matt, this one's going to be for you. It's a little bit on the lengthy side, but can you elaborate a bit more on the compliance aspects? Our company is in Europe and would require EU electrical classification, example, a text. Can these be configured for EU electrical? Matt?
Yes, thanks for the question. So we have built many systems for the Europe market, and we are familiar with the requirements, but each area may have different requirements, and we want to have a discussion with you to understand more about the requirements.
Very good. Kathleen, this one is for you. Can sampling ports be included in between the two columns?
Yes, if you remember the slide with the P&ID, you could see sample ports installed there. This is for smaller skid, so depending on the sizing of the skids, the sampling ports have to be engineered appropriately, but they can be placed on the outlet of either on the outlet of the columns or in front of your fraction collection valve if you want to monitor your fraction. So there are some options available, and we can talk with you about this in more detail.
Good. And Kathleen, we're going to stick with you. Is there conductivity UV behind each column?
Yes, behind each column you will find the traditional UV flow cells where we choose dual wavelengths flow cells where you can adjust your wavelengths to your needs. But because it's an HPLC application, conductivity and pH probe have to be on the low pressure side. So they're usually just in front of the outlet valves installed, so you can monitor the outlet flows from the system instead of the flows of the columns. That is an adjustment because high pressure conductivity and pH probes are not available, or we have not found the right one to implement within the cycle.
I think you can also indicate that there's not special columns required for this process. Is that correct?
Yes, that is correct. So any HPLC column, pre-pack columns you have, the only requirement is, because we do the internal recycling, that both columns should have a similar characteristics. So they're packed with the same resin or packing material, and they should be packed to the same procedure and have the same characteristics within a particular variability to meet the requirements. And again, in the real world, things cannot be the same. We have this end control tool, which then, helps to adjust to variability in your process parameters. Thank you.
Okay, we've got about 2 minutes left, and we have a couple of questions. If we don't get to all the questions, we will copy them down and get back to it in writing. This one, Matt, two-part. What is the approximate footprint, and how long do these systems take to manufacture?
Sure. The system that we are building is 72 inches long, 50 inches wide, and 80 inches high. And the weight estimated to be like 3,600 pounds. So these systems are not really off the shelf, and we make to order, and usually it takes 24 or 34 weeks to manufacture and complete, including testing.
But generally, you'd expect them to be able to fit through typical industrial doorways in a manufacturing environment?
Absolutely. Yeah.
Okay. One for Kathleen. Can the methods from the cube be imported to the GMP system? If not, how is that transfer done?
So we are developing a transfer template, so you can do your development work on the cube using the wizard as explained in the coding webinar, and then this data will then be imported into the recipe. Of course, because we're in a GMP environment, operator, supervisor have to verify the data. You might want to check, with your process in particular, but process parameters like flow rate, switching times can be transferred with this template into your recipe and pre-populate your recipe. Yes, that is possible.
Very good. I want to thank you all for your questions and your participation today. I have my eye on the time and want to respect your time that you've committed to this. So again, thank you for your questions, your participation. If you've got any immediate questions you would like to ask the speakers directly, you can just send those to us at info@ymcpt.com. That's info@ymcpt.com. Again, in the coming days, you'll receive a link to the archive version of this presentation and associated reference documents. So please feel free to share those with your colleagues. We encourage that. And as a reminder, this is one in a series of about 15 webinars around these topics of multi-column chromatography and the purification of advanced proteins. We'll end our session now. Thank you and have a pleasant day.